While we ponder stars, we likely imagine little sparkling articles in the evening sky. At least, this is how we see them from down here on Earth. However, stars are very different. For example, one of the largest stars, Betelgeuse, is impressively larger than our Sun. For many years, this star has perplexed scientists, yet recently, truly unusual phenomena have been happening with Betelgeuse, causing researchers and other learned individuals to become quite concerned. Join us in this video as we dig into the fascinating data about Betelgeuse, its potential end as estimated by the James Webb Telescope, and how this new development may impact our cosmic system and our world here on Earth. As described by physicist Michio Kaku, Betelgeuse is an enormous wonder, a massive star that has intrigued astronomers for a long time. A Greek astronomer named Timarchus was the first to identify it. This star is so gigantic that it can be seen in the night sky from Earth, especially during winter. If you're interested in constellations, you've probably noticed or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. This star is old and is currently one of the brightest stars in the night sky. One interesting aspect of Betelgeuse's brightness is that it doesn't remain constant. Rather, it changes. This variability is one of the unique features of this star, though it is not the only one. Let's examine some of Betelgeuse's distinct characteristics. Most of the stars you see in the night sky are very far from Earth. The closest star is 4.2 light-years away. If you're unsure of what light years means, picture moving at the speed of light for an entire year. Light can travel at a speed of 186,000 miles per second, so the distance light can cover in a year equals 1 light-year, which is billions of miles. So, when we say the closest star is 4.2 light-years away, it means it is billions of miles from Earth. Yet, some stars are even farther away, and Betelgeuse is one of them. Betelgeuse is located roughly 600 light-years from Earth. Therefore, if you were to travel to it at light speed, it would still take 600 years. We can't move that fast, not even with our quickest rocket, but it still shines brightly in our sky. If you're curious about how Betelgeuse can be so luminous despite its distance, it's due to its unique characteristics like size and brightness. Betelgeuse is around 500 times larger than our Sun, and its radius is estimated to be more than 1,000 times that of the Sun. It is so massive that it appears as a disk in space when using advanced telescopes, while other stars appear as small points of light. This phenomenon is thought to be due to reactions happening in the outer layers of its atmosphere. In terms of mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers, equivalent to 2 times 10 to the power of 30 kg. Scientists cannot determine the exact mass of Betelgeuse because there are no planetary bodies orbiting it for comparison, and we can't measure it directly from our planet. However, it has been established that this star is at least 12 times more massive than our Sun. The brightness of Betelgeuse varies from a magnitude of plus 0.0 to plus 1.6. In more relatable terms, Betelgeuse is over 10,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, Betelgeuse's brightness is not consistent. It fluctuates due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it becomes brighter, but when it contracts, it dims. This cycle can last from 10 to 100 days or even longer. One unique characteristic of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than the usual surface. However, the downside is these strong magnetic spots hinder the flow of hot gas to the star's outer surface, causing the star to be cooler in those areas. The fact that Betelgeuse has many more of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice the size of Earth. Betelgeuse also has a magnetic field that is about 100 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on Betelgeuse's surface appear to form arcs or loops. Betelgeuse has a surface temperature of around 3,500 Kelvin. This low temperature contributes to the reduced energy emitted by the star and its faint red color. Betelgeuse is a red star, though it wasn't always red. Around 2 million years ago, Betelgeuse looked like our Sun throughout the long years. Its color started changing to orange-red, and about 40,000 years ago, it gradually began turning into the red star we recognize today. This fact has led scientists to believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the Sun, making it a considerable counterpart to Earth's Sunday. If it were not so far off, the reality that Betelgeuse, 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes from Earth, which is why it is so powerful. If Betelgeuse were a bit closer, we would also be able to see it during the daytime. However, if it were to replace the Sun, it would engulf or displace Earth and the other 4 neighboring planets due to its enormous size. Besides, even if it could match the Sun, it emits more radiation than our Sun, which alone would render it an unsuitable sun for Earth. So maybe it was never meant to be our Sun, just a distant, enormous red star that we can appreciate and study from afar. The red light from Betelgeuse is much more pronounced because of its distance from Earth. One aspect of the universe is that it is continuously expanding. This expansion changes the light waves from objects and galaxies, causing only longer wavelengths of light to travel farther. Red light has a longer wavelength than blue light, so at great distances, blue light won't be visible, only red light. However, as captivating as Betelgeuse has been all these years, one thing remains clear: it is an old star nearing the end of its lifespan. Stars become red toward the end of their lives when the hydrogen in their cores converts into helium through nuclear fusion. At this stage, the star gradually changes into what astronomers refer to as a red giant. From what we know about stars, massive stars age more quickly than lighter stars. Since Betelgeuse is approximately 15 to 20 times more massive than the Sun, it is dying at an accelerated rate. The star's irregular pulsations and brightness are further solid indicators that it is nearing the end. Betelgeuse began dimming in 2019, but its lowest brightness ever recorded was in February 2021. This is when concerns about the star's imminent end state began to grow within the scientific community. But wait a minute, how do stars die? Well, they explode in an event scientists call a supernova. So, what is a supernova? If you've ever seen a nuclear explosion, know it pales in comparison to a supernova. A supernova is a titanic and powerful explosion that occurs when stars reach the end of their life. A tremendous amount of energy is usually released into space whenever a supernova occurs, making these events some of the universe's most brilliant and awe-inspiring occurrences. However, there are 2 types of supernovae, Type 1 and Type 2. A Type 1 supernova happens when the remnant of a low-mass star accumulates matter from a companion star until it reaches a critical mass it can no longer support. This triggers a nuclear reaction resulting in the star's explosion. A Type 2 supernova occurs when high-mass stars like Betelgeuse exhaust their fuel and can no longer support their own structure. As a result, the star explodes, releasing a massive amount of energy. A typical Type 2 supernova will emit light, heat, and radiation. They can be so powerful that they can destroy everything in their path. Sometimes, a Type 2 supernova can emit light so bright that it outshines all the other stars in its galaxy. Type 2 supernova explosions also produce heavy elements like iron, nickel, and gold. These metals are created during the high-pressure and high-temperature reactions and are scattered into space as the star explodes. As they enter space, they contribute to the formation of new stars that will emerge from the supernova remnants. Supernovae generally result in the creation of new stars or planets. Thank you for reading. Here's the continuation. If it speeds faster than light or if the shockwave may reach us sooner than expected due to unforeseen factors, it could alter timelines. However, while scientists and astronomers may have differing views on the potential danger posed by Betelgeuse, one thing remains certain. The universe is full of surprises, and our understanding of it is constantly evolving. So, is the possibility of Betelgeuse going supernova good news or bad news? It's challenging to say for certain. A cosmic explosion occasion could be a stunning galactic exhibition, possibly apparent even during daylight hours. On the other hand, the repercussions for life on Earth could be devastating. Eventually, it serves as a reminder of the tremendous power and unpredictability of the universe and the significance of ongoing scientific exploration and understanding. Whether Betelgeuse's fate will directly impact us or not, its story provides a captivating look into the mysteries of the universe and our place within it. Following its blast, Betelgeuse may trigger the spontaneous formation of another star. Capella is only 43.3 light-years away, and if a star like that were to be activated, Earth would certainly suffer the repercussions. We can only hope we are safe from the impact and that it doesn't affect us directly. But what other effects might we experience from Betelgeuse's blast? Primarily, it would involve light effects. A supernova mainly releases light and energy. If Betelgeuse detonated, you would witness its brilliant light overhead no matter where you were on the planet. As we consider the vastness of space and the celestial bodies that occupy it, Betelgeuse stands out as a star of extraordinary size and complexity. Located around 600 light-years from Earth in the Orion constellation, Betelgeuse, also known as Alpha Orionis, has captivated the imagination of astronomers and stargazers for centuries. Its distinctive reddish-orange color marks it as a prominent member of the night sky, visible even to the unaided eye during certain seasons. The sheer size of Betelgeuse is astounding, around 500 times larger in diameter than our Sun, with a mass estimated to be between 12 to 17 times that of the Sun. Betelgeuse is classified as a red supergiant, a classification that places it among the largest known stars in the universe. Its massive size isn't just a matter of scale, it also has significant implications for its life cycle and ultimate destiny. Stars like Betelgeuse are born from vast clouds of gas and dust that collapse under their own gravity to form dense cores. Over thousands of years, these cores heat up and start nuclear fusion, converting hydrogen into helium and releasing tremendous amounts of energy in the process. This fusion process supplies the energy that sustains a star throughout its main sequence stage. However, Betelgeuse has already exhausted much of its hydrogen fuel. Like all stars, it is in a constant battle between the inward pull of gravity and the outward pressure generated by nuclear fusion. As hydrogen fusion decreases in its core, the balance shifts, and the star begins to expand outward, becoming cooler and redder, a change marking the beginning of its transformation from a main sequence star to a red giant. The evolutionary path of Betelgeuse is characterized by its irregular pulsations and variable brightness. These pulsations arise from complex interactions within its atmosphere, where energy generated in its core passes through layers of gas, causing them to rhythmically expand and contract. This fluctuation in brightness, known as its light curve, can last from weeks to months. For astronomers, studying these pulsations provides significant insights into the internal structure and dynamics of massive stars nearing the end of their lives. One of the most intriguing aspects of Betelgeuse is its tendency to undergo sudden dramatic fluctuations in brightness. In late 2019 and early 2020, astronomers observed extraordinary dimming episodes where Betelgeuse's glow dropped to levels never previously recorded. These dimming events sparked speculation and debate among scientists regarding the underlying causes and potential implications for the star's future. One hypothesis proposed to explain Betelgeuse's recent dimming episodes involves the formation of massive, dense clouds of dust and gas in its surrounding environment. These opaque clouds could temporarily obscure the star's light as they drift across our view, resulting in noticeable dimming. Another theory suggests that the dimming might be connected to fluctuations in the star's internal processes, such as variations in convection or pulsation activity. Despite these episodes of dimming, Betelgeuse remains a beacon in the night sky, visible to observers on Earth as one of the brightest stars in the Orion constellation. Its luminosity, combined with its enormous size, makes it a celestial marvel and an object of intense study for astronomers seeking to unravel the mysteries of stellar evolution and cosmic dynamics. Betelgeuse's future, however, is far from certain. As a red supergiant nearing the end of its life, it faces an inevitable fate shared by all stars of its type, a massive finale as a supernova explosion. Supernovae are among the most powerful and energetic events in the universe, capable of briefly outshining entire galaxies and releasing tremendous amounts of heavy elements essential for the formation of new stars and planets. The prospect of Betelgeuse going supernova has captivated both the academic community and the public alike. While astronomers have long anticipated such an event, predicting when it will happen remains challenging. Supernovae are notoriously unpredictable, with the timing of each event dependent on a delicate balance of factors, including the star's mass, composition, and internal dynamics.